So first we have Karsten Monk, the board director for Cartesi. Is that correct?
Yes.
Awesome, welcome.
Okay. So let's get started. So I'm here to talk to you about Cartesi as a Linux coprocessor. And I don't want to kind of describe how it's built. I want to explain to you how you can build with it. So let's start. What is this kind of AVS? It's a crypto-economic coprocessor with attributable fault. And it basically means that you can write a coprocessor function as modern Linux software. So basically anything you can do right now in terms of Linux, in terms of, let's say, computing Doom replays, in terms of kind of like running AI models, this is something you can do with the Cartesi coprocessor. It supports popular languages like Go, Rust, TypeScript, et cetera, and pretty much all the existing libraries that you have in the Linux ecosystem. And how is this done? It's done with the reproducible, deterministic, 64-bit RISC-V Linux-capable Cartesi virtual machine. And just to make it completely clear, this is really simple to do. You can compile a Docker container to RISC-V with our Cartesi CLI. You can make that result of this computation available on IPFS. You pay or you run a computation solver, make it orchestrate and call back to your smart contract. You can issue tasks from your smart contract and run a Raspberry Pi. And using the power of eigenlayer and consensus and votes and operators and so on, basically you can receive, let's say, a proven callback with function outputs directly on your smart contract. It's not something that we are making up today. It's here today. It's single operator right now, pre-production, but it is on mainnet. One of the things we want to do in the future, L2 support, Ethereum history access, data availability layer like Espresso, EigenD, and so on, IPFS, TE, and acceleration, like, for example, externalizing matrix multiplication. If you want to, you can go and scan this and actually start developing, for example, Python now. That's bit much.
Thank you. Awesome, perfect timing. And I apologize for my mispronunciation of Cartesi. So we have questions now for 1 minute. So does anyone have any questions that they want to learn more about Cartesi? We have one right back here.
Thank you. I'm curious, how does it fundamentally work? Like, do you prove the whole execution of a Linux virtual machine?
So basically, this is standard replicated computation, right? We have a deterministic virtual machine, which means it runs exactly the same way on any hardware, anywhere, right? And then basically, if an operator goes out and signs the wrong computation result, we go ahead and actually slash them later on through a fraud-proof system. So basically, this is pretty much how it is. You don't need to prove the whole execution, you just basically sign it, and then you get caught later, a little bit like the guillotine coming from the French royalty.
Any other questions?
I do, I think.
Okay, thank you.
Thank you.